Hello, Matthews Gatos here. In this video, I'm going to prove to you what the derivative of b to the x is. So let's get started. So if I'm looking at this exponential function b to the x, b is just a number base. For this to be an exponential function, we know that the base has to be a positive number, and it can't be 0, and it can't be 1. So b is equal to a positive number, b can't be 0, and b can't equal 1. So we say we're going to find the derivative of b to the x where b is greater than 0, not equal to 0, but also not equal to 1. So to look at this, the only thing I have in my toolkit right now is that the derivative of e to the x is e to the x. So I want to somehow use that to help me. So I'm going to use the fact that exponential functions and log functions are inverse relationships. So for example, using this e, I want to use this e somehow. I know that if I take e and raise it to the log with the same base of e to the x, these cancel each other out. Exponent with a base of e raised to a log exponent with a base of e, those undo each other to be just x. So if I want to introduce the b in there, I can say that e to the log base e of b, same argument, they undo each other, cancel each other out to be just b. So we don't really say log base e, we call that a natural log. So log base e is natural log. So I know that e to the natural log of b is also equal to b. They cancel each other out using that inverse relationship. So if I want to write b to the x using that e, I can write this as e to the natural log of b all to the x. And now this derivative is going to help me out. So if I have y equals e to the natural log of b to the exponent of x, and I want to find the derivative, I'm going to use this rule. Now this rule is when the exponent is just x. When the exponent is not just x, I have to use chain rule. So chain rule says the derivative of e to the u is equal to e to the u itself multiplied by the derivative of the exponent. So my derivative is going to be e to the natural log b all to the x multiplied by the derivative of the exponent. So let me just write that out. The derivative of the exponent, which is natural log b times x. Okay, so e to the natural log of b, we've already established that those undo each other, they cancel to be b. So that whole thing on the inside is just b to the x multiplied by the derivative of ln b times x. Well, this is just, ln b is just a number. So I know, for example, if I had the derivative of 2x, it would just be the number 2. So the derivative of ln bx would just be ln b. So what I've done here is I have proved to you that the derivative of b to the x is b to the x multiplied by the natural log of b. So now that we have that proved, we can use it for all questions that follow, and we can use this in any subsequent proof. So I hope this video helped. If it did, please give it a thumbs up and hit subscribe so I can help more mathies just like you. Thanks for watching, and we'll see you for the next one.